Good afternoon. Just give me one moment and we'll get started. Running a little late today. So just need to get my G Fuel ready. Starting to hit the bottom of this tub. All right. So today we are going over debugging and basic data structures for the JavaScript algorithms and data structures certification on Free Code Camp. Debugging is a valuable and unfortunately necessary tool for programmers. It's true. It follows the testing phase of checking if your code works as intended and discovering if it does not, Debugging is the process of finding exactly what isn't working and fixing it. After spending time creating a brilliant block of code, it is tough realizing it may have errors. These issues generally come in three forms. Syntax errors that prevent a program from running, runtime errors when code fails to execute or has unexpected behavior, and semantic or logical errors when code doesn't do what it's meant to. Modern code editors and experience can help identify syntax errors. Semantic and runtime errors are harder to find. It may cause your program to crash, make it run forever, or give incorrect output. Think of debugging as trying to understand why your code is behaving the way it is. Function will not work. What's wrong here? Function keyword is misspelled. And there's a missing parentheses right here. Here's an example of runtime error, often detected while the program executes. Calling loopy starts an infinite loop. While true, console log, hello world. And true is always true. So we get an infinite loop. Example of a semantic error, often detected after testing code output. So we have the area of a rectangle, term width plus height. This should be width times height. So when you use it, it's wrong because you've done the wrong thing. Debugging is frustrating, but it helps to develop and follow a step-by-step approach to review your code. This means checking the intermediate values and types of variables to see if they are what they should be. You can start with the simple process of elimination. For example, if function A works and returns what it's supposed to, then function B may have the issue. Or start checking values in a block of code from the middle to try to cut the search space in half. A problem in one spot indicates a bug in the first half of the code. If not, it's likely in the second. Problem in one spot indicates a bug in... Okay. This section will cover a couple helpful tools to find bugs and some of the common forms they take. Fortunately, debugging is a learnable skill that just requires a little patience and practice to master. It's true. It's very true. When I first started coding, that's probably one of the most taunting things is you're following along to some tutorial and you do something and something really small and you can't notice it. And it takes you forever. Both Chrome and Firefox have excellent JavaScript consoles, also known as dev tools, for debugging your JavaScript. You can find developer tools in your Chrome's menu or web console in Firefox's menu. If you're using a different browser or a mobile phone, we strongly recommend switching to desktop Firefox or Chrome. The console log method, which prints the output of what's within the parentheses to the console, will likely be the most helpful debugging tool. Placing it at strategic points in your code can show you the intermediate values of variables. It's good practice to have an idea of what the output should be before looking at what it is. Having checkpoints to see the status of your calculations throughout your code will help narrow down where the problem is. Here's an example to print hello world to the console. Console.log hello world. Use the console.log method to print the value of the variable a were noted in the code. Add your code below this long line. So it wants to print the value of variable a. So we just do console.log and we do a. Because we have a equals 5, but we're expecting a to be 6. So we just want to check that a is indeed 6 here before we give out the sum. Understanding the differences between the FreeCodeCamp and Browser Console. You may have noticed that some FreeCodeCamp JavaScript challenges include their own console. This console behaves a little differently than the Browser Console you used in the last challenge. The following challenge is meant to highlight some of the differences between FreeCodeCamp console and the Browser Console. First, the browser console. When you load and run an ordinary JavaScript file in your browser, the console.log statements will print exactly what you tell them to print to the browser console the exact number of times you requested. In your in-browser text editor, the process is slightly different and can be confusing at first. Values passed to console log and the text editor block run each set of tests, as well as one or more time for any function calls that you have in your code. This lends itself to some interesting behavior and might trip you up in the beginning, because a logged value that you expect to see only once may print out many more times depending on the number of tests and the values being passed to those tests. If you'd like to see only your single output and not have to worry about running through the test cycles, you can use console.clear. Use console.log to print the variables in the code where indicated. Use console.log to print the output to variable. So we just console.log output to. And then it says use console clear in the next line to print the output 1 only once. Okay. So we console.clear, and then it wants us to console.log output 1. Use typeof to check the type of a variable. You can use typeof to check the data structure or type of a variable. This is useful in debugging when working with multiple data types. If you think you're adding two numbers but one is actually a string, the results can be unexpected. Type errors can lurk in calculations or function calls. Especially take care when you're accessing and working with external data in the form of a JavaScript object or JSON. Here are some examples of using typeof. So console.log, we're looking at the type of this, which is a string. This is a number, array, object. JavaScript recognizes 6 primitive, immutable data types: Boolean, null, undefined, number, string, and symbol. which is new with ES6, and one type for mutable items object. Note that in JavaScript, arrays are technically a type of object. Add two console.log statements to check the type of each of the two variables, 7 and 3, in the code. So we need some console.logs here, and we want to check the type of 7. And because we don't like typing, we're going to copy that line. Whoops. And just change this to 3. And not type, type of. That should get rid of those errors. We can run our code. Catch misspelled variable and function names. The console log and type of methods are two primary ways to check intermediate values and types of program output. Now it's time to get into the common forms that bugs take. One syntax level issue that fast typers can commiserate with is the humble spelling error. Transposed, missing, or miscapitalized characters in a variable or function name will have the browser looking for an object that doesn't exist and complain in the form of reference error. JavaScript variable and function names are case sensitive. Fix the two spelling errors in the code so that net working capital calculation works. Let's see here. So we have net working capital. This is working. It's spelled right and everything, but how this is calculated, receivable, payable. Look at receivables. We got our I before our E. In the case of C, so that's not right. So we fix that. Receivables, payable should be payables. And that should do it. Unclose parentheses, brackets, braces, and quotes. Another syntax error to be aware of is that all opening parentheses, brackets, curly braces, and quotes have a closing pair. Forgetting a piece tends to happen when you're editing existing code and inserting items with one of the pair types. Also take care when nesting code blocks into others, such as adding a callback function as an argument to a method. One way to avoid this mistake is as soon as the opening character is typed, immediately include the closing match, then move the cursor back between them and continue coding. Fortunately, most modern code editors generate the second half of the pair automatically. Fix the two pair errors in the code. It's got a little red squiggly line here. It tells us there's an error. And we can see the array is not properly set up. And here, this is a common mistake I make all the time. We got one parentheses, but we look. A nice thing that these IDEs will do, we have this one selected here. You can see this white box. It will highlight its pair. So you can see right next to this, there's another parenthesis that doesn't have a match here. We'll click both sides of it and it doesn't get that white box. Until we do this. And now you can just watch right here. And it said there's two pairs. So that should do it. Previous is not defined. Oh, okay. This actually doesn't go here. It's supposed to go here. This is a collection of parameters, and since we have more than one, you do need that. Alright. Catch mixed usage of single and double quotes. JavaScript allows the use of both single and double quotes to declare a string. Deciding which one to use generally comes down to personal preference, with some expectations. Having two choices is great when a string has contractions, or another piece of text that's in quotes. Just be careful that you don't close the string too early, which causes a syntax error. Here are some examples of mixing quotes. These are correct. So we got, I've had a perfectly wonderful evening, but this wasn't it. So that allows us to use these single quotations because we've started out with a double. And again, same here. And this would break because JavaScript would say, oh, there's a string here. And then it'll look at the I, and then it'll be like, all right, here's the end of the string. So that's not good. Of course, it's okay to use only one style of quotes. You can escape quotes inside the string by using the \escape character. So here's the same I example. It's fixed because it's using backslashes. So JavaScript sees this. Oh, here's a string I. Oh, well, there's a backslash, so we can go ahead and keep going. Another one here, and now here's the end of the string. Fix the string so it either uses different quotes for the href value or escape the existing ones. Keep the double quote marked around the entire string. So we can do either. We'll just escape, just because it's easier, I guess. Catch use of assignment operator instead of equality operator. Branching programs, i.e. ones that do different things if certain conditions are met, rely on if, else if, and else statements in JavaScript. The condition sometimes takes the form of testing whether a result is equal to a value. This logic is spoken, in English at least, as if x equals y, then stuff, which can literally translate into code using the equal or assignment operator. This leads to unexpected control flow in your program. As covered in previous challenge, the assignment operator, a single equal sign in JavaScript, assigns a value to a variable name, and the double equal or triple equal operators check for equality. The triple tests for strict equality, meaning both value and type are the same. Code below assigns x to be 2, which evaluates as true. Almost every value on its own in JavaScript evaluates to true, except what are known as falsy values. False, 0, an empty string, not a number, undefined, and null. We got an example here. We have x equals 1, y equals 2, and then this is wrong because it says if x equals y, and this is an assignment. You need to use the double or triple equal signs there. So what it's actually doing is x equals y. So y, value of y is coming over and replacing, so x will be 2. And then it's just checking if 2, and 2 is a number that evaluates true because it's not 0. Fix the condition so the program runs the right branch and the appropriate value is assigned to result. So we got x equals 7, y equals 9. The result is to come. If x is equal to y, and we don't want to do that, we want to do double. That should be fine. Catch missing open and closing parentheses after a function call. When a function or method doesn't take any arguments, you may forget to include the empty opening and closing parentheses when calling it. Oftentimes, the result of a function call is saved in a variable for other use in your code. This error can be detected by logging variable values or their types to the console and seeing that one is set to a function reference instead of the expected value the function returns. Variables in the following example are different. So function, my function equal, it returns you rock. So here actually makes var1 this function. var2 runs my function, so you get this. Well, you get you rock. Fix the code so the variable result is set to the value returned from calling the function get9. So we have a function get9. It has x is 6 and y is 3, and it's returning x plus y, which should equal 9, hence the name. Right now it has this result is set to get9, but that's actually the whole function. So we could actually, if we wanted, we could do this. Because this is now the function. I don't think this is going to work, but we'll test it. No. So that would like work to use it. But what it wants us to do is do it here. Catch arguments passed in the wrong order when calling a function. Continuing this discussion on calling functions, the next bug to watch out for is when a function's arguments are supplied in the incorrect order. The arguments are different types, such as a function expecting an array and an integer. This will likely throw a runtime error. If the arguments are the same type, all integers for example, then the logic of the code won't make sense. Make sure to supply all required arguments in the proper order to avoid these issues. The function raise to power raises a base to an exponent. Unfortunately, it's not called properly. Fix the code so the value of power is the expected 8. Okay, so basically this example is we have our function here, and we have raised to power. It accepts a B and a E. Because this function here, first number, the X number here, the first value is supposed to be your base, and then the Y, the second, is supposed to be what are they called? Exponent. So base, exponent, B and E makes sense, right? So we look down here, we have our base is 2, our exponent is 3. So 2 times 2 is 4, times 2 is 8. That's what we're looking for. But then when you get here, let power equals raised to power. And the order that we're setting these in, we're sending first the exponent, then the base, which gives us 3 times 2. Well, no, 3 times 3, sorry. Which is 9. 9. So what we need to do is flop these around so that they match and work. Catch Offbyone errors when using indexing. Offbyone errors, sometimes called oboe, crop up when you're trying to target a specific index of a string or array to slice or access a segment, or when looping over the indices of them. JavaScript indexing starts at 0, not 1, which means the last index is always 1 less than the length of the item. If you try to access an index equal to the length, the program may throw an index out of range reference error or print undefined. When you use string or array methods that take index ranges as arguments, it helps to read the documentation and understand if they are inclusive. the item at the given index is part of what's returned or not. Here are some examples of off by one errors. So we have the string alphabet, it has the alphabet. The length is alphabet length. And we're setting up a for loop here to log out all of them. But like this just said, the length will give us how many characters, while the indexes are one less. So 26 characters, but 25 indexes. So when we go through this, it's gonna error out. This one fails because we're starting at 1 and indexes start at 0. And then this one works. This one works because this one didn't work because it was doing less than or equal to, and this one is less than. You could have also did like -1, but the check there I think is better, yeah. Fix the 2 indexing errors in the following functions so all the numbers 1 through 5 are printed to the console. So we have our first 5 string here, 1, 2, 3, 4, 5. The length is first 5 dot length, and we're going to fix this line below. So right now it starts at 1 when it needs to start at 0. And we need it to be less than the length. The length is 1 more than the number of indices. However you say that word. Use caution when reinitializing variables inside a loop. Sometimes it's necessary to save information, increment counters, or reset variables within a loop. A potential issue is when variables either should be reinitialized and aren't, or vice versa. This is particularly dangerous if you accidentally reset the variable being used for the terminal condition, causing an infinite loop. Printing variable values with each cycle of your loop by using console.log can uncover buggy behavior related to resetting or failing to reset a variable. The following function is supposed to create a 2-dimensional array with m rows and n columns of zeros. Unfortunately, it's not producing the expected output because the row variable isn't being reinitialized. Set back to an empty array in the outer loop. Fix the code so it returns a correct 3x2 array of zeros, which looks like we have our single array and within it 3 arrays of 2 zeros each. Creates a 2D array with m rows and n columns. So I believe this is it. Wait. Alright, so we got our new array, we have the row. For every row, we're going to push in zeros. So we need to reset our row. Nice. Alright. So yeah, we need to reset the row because it's going through here. We have our this new array here is this wrapping. And so this never really changes because we're just going to keep pushing into this one array. But our row, we have an empty row, and then we're setting it up here, mostly here. And the row starts as an empty one of these, and then we're pushing in the number of zeros for each one. And then when we take the new array and we push in the row, and we go back up because we're still doing this for loop, because we have 3 of them to do, the next time that it pushes in the row, it already has 2 zeros in it. So you got 2 zeros, and then it's adding, next one is adding 4 zeros, and then 6 zeros, I believe, and so on. So we need to reset the row after we push, so we can just do that like this. Prevent infinite loops with a valid terminal condition. The final topic is the dreaded infinite loop. Loops are great tools when you need your program to run a code or block a certain number of times or until a condition is met. But they need a terminal condition that ends the looping. Infinite loops are likely to freeze or crash the browser and cause general program execution mayhem, which no one wants. There was an example of an infinite loop in the introduction to this section. It had no terminal condition to break out of the while loop inside loopy. Do not call this function. Don't paste this into your browser and use it. It's the programmer's job to ensure that the terminal condition, which tells the program when to break out of the loop code, is eventually reached. One error is incrementing or decrementing a counter variable in the wrong direction from the terminal condition. Another one is accidentally resetting a counter or index variable within the loop code instead of incrementing or decrementing it. The myFunction function contains an infinite loop because the terminal condition I is not equal to 4 will never evaluate to false and break the looping. I will increment by 2 each pass and jump right over 4 since I is odd to start. Fix the comparison operator in the terminal condition so the loop only runs for I less than or equal to 4. So this is going to keep going because we start with 1. And then to check to see if we go in here, we go into this next block here, and if I is not equal to 4, and 1 currently is what I is equal to, so 1 does not equal 4, so it will log still going, and after we'll do this I plus equals 2, which would make I is currently 1, 1 plus equals 2 would be 3. So we would come back here and we check again. Is 3 not equal to 4? Sure is, so we're gonna log this out. And then we're gonna add another 2 to I. And that's when it skips. It goes right to 5. So it's just gonna keep going. Keep going. Keep going. So to fix that, it wants it to be less than or equal to 4. So it will only do it 3 or 4 times. Or a couple times. Or once. Let's see here. That's it for debugging. We're 40 minutes in. I will be right back. I just need to do a Twitch thing. I want to mark this. Oh, did that not work? Stream markers. Let's see here. Starting basic data structures. Boom. Okay. I'm gonna hide myself for a second. Take a short little break here, and we'll move on to this next section. You know, full glasses here. All right, introduction to the basic data structure challenges. Data can be stored and accessed in many different ways, both in JavaScript and other languages. This section will teach you how to manipulate arrays as well as access and copy the information within them. It will also teach you how to manipulate and access the data within JavaScript objects using both dot and bracket notation. When you're done with this section, you should understand the basic properties and differences between arrays and objects, as well as how to choose which to use for a given purpose. Let's go to the first lesson. First lesson is how to use an array to store a collection of data. Arrays are... there was a time when I didn't understand an array. And I just didn't get it. And then I just started to think of them as like buckets of data. Like it's just a collection. It's a list. That's all it is. Anyway. Tableau is an example of the simplest implementation of an array data structure. This is known as a one-dimensional array, meaning it only has one level, or that it does not have any other arrays nested within it. Notice it contains Boolean, strings, and numbers, among other valid JavaScript data types. All arrays have a length property, which, as shown above, can be very easily accessed with the syntax array.length. And that just means you use it on any array, just like they do here. More complex implementation of an array can be seen below. This is known as a multi-dimensional array, or an array that contains other arrays. Notice that this array also contains JavaScript objects, which we will examine very closely in our next section. But for now, all you need to know is that arrays are also capable of storing complex objects. So a multi-dimensional array is just a list of lists. This could be an array of like posts for your blog, or an array of your favorite movies. So you would have this outer array would be like this would be called favorite movies, and this outer array would contain each movie, and each array within it would be a movie. This is almost 3 layers deep, because objects are sort of arrays too, just different, do fun things. So yeah, pretty awesome. We have defined a variable called your array. Complete the statement by assigning an array of at least 5 elements in length to your array variable. Your array should contain at least 1 string, 1 number, and 1 Boolean. So we're gonna make an array. Let's make an array. That's how you do it right there. Here's an empty one. And we need 1 string. Hello chat. And we need 1 number, which will be 42. And 1 Boolean, which is going to be false. But we need 5 elements, so we need 2 more. And we'll just do 1 and 2. Access an array's contents using bracket notation. The fundamental feature of any data structure is, of course, the ability to not only store data, but to be able to retrieve that data on command. So, now that we've learned how to create an array, let's begin to think about how we can access that array's information. When we define a simple array as seen below, there are 3 items in it. So we have our array. It's an array with 3 strings, A, B, and C. In an array, each array item has an index. The index doubles as the position of that item in the array and how you reference it. However, it is important to note that JavaScript arrays are 0 indexed. This is like the 3rd time we're hearing about that. Meaning that the first element of an array is actually at the 0th position, not the first. In order to retrieve an element from an array, we can enclose an index in brackets and append it to the end of an array, or more commonly, to a variable which references an array object. This is known as bracket notation. For example, if we want to retrieve the A from our array and assign it to a variable, we can do so with the following code. Let our variable equals our array 0. And since it's the 0th index, we go 0, 1, 2. And we're getting the 0th index, so we're getting A. In addition to accessing the value associated with an index, you can also set an index to a value using the same notation. So our array will take the first index, which is the 2nd item in the array, and we're going to equal it. We're going to make it not B anymore. So now our array would be A, which is the 0 index, and then the 1 index right here is what we just set it to, and then C. Using bracket notation, we have now reset the item at index 1 from B to not B anymore. be or not to be. In order to complete this challenge, set the second position, index 1, of my array to anything you want besides B. So it just wants us to my array, and we're getting second, so 1. And we're gonna make it E. That's the next letter. Let's see here. Add items to an array with push and unshift. An array's length, like the data types it can contain, is not fixed. Arrays can be defined with a length of any number of elements, and elements can be added or removed over time. In other words, arrays are mutable. In this challenge, we will look at 2 methods which we can programmatically modify an array: array push and array unshift. Both methods take 1 or more elements as parameters and add those elements to the array the method is being called on. The push method adds elements to the end of an array, and unshift adds elements to the beginning. Consider the following. So we have a variable 23, which is just Roman numerals for 23. And then we have an array of Roman numerals. We have 21, 22. I'm guessing they're going to want to stick 23 in here. And so we're taking Roman numerals unshift, and this is 19, 20, so that should put them at the beginning. So now it's 19, 20, 21, 22, and finally they're going to push 23 to the end, so 20 or 19, 20, 21, 22, 23. Notice that we can also pass variables, which allows us even greater flexibility in dynamically modifying our array's data. So yes, in this example, they just straight up, these are the things that we want to put in there. You can use a comma separated list. In this example, we passed a variable. We have defined a function, mixed numbers, which we are passing an array as an argument. Modify the function by using push and unshift to add I, 2, 3 to the beginning of the array and 7, 8, 9 to the end of the array, so that I see, 1, 2, 3, 7, 8, 9 to the end, so that the returned array contains representations of the numbers 1 through 9 in order. So we have our function here that we're going to change. Mixed numbers, it's getting passed in an array. It's being used here. Mixed numbers, we're passing in 4, 5, and 6. So we're going to want to take this and array unshift to put it at the beginning. We're going to put I, 2, and 3. And we don't need to do this. Save myself some characters there. And then we need to push, which we'll put at the end, and we're going to put 7, 8, and 9. Perfect. Remove items from an array with pop and shift. Both push and unshift have corresponding methods that are nearly functional opposites, pop and shift. As you may have guessed by now, instead of adding, pop removes an element from the end of an array, while shift removes an element from the beginning. The key difference between pop and shift and their cousins push and unshift is that neither method takes parameters, and each only allows an array to be modified by a single element at a time. Let's take a look. Alright, so we have this greetings array with different greetings. What's up? Hello, see ya. And if we do greetings.pop, Now the array will equal what's up and hello, because pop takes and removes the last one. And if we greetings shift, now greetings will equal just hello because it takes away the first one. You can also return the value of the removed element with either method like this. So let popped, we just put it in a variable. So greetings popped, and now finally it would return hello, and greetings would be empty because we've taken everything out. We have defined a function, popShift, which takes an array as an argument and returns a new array. Modify the function using pop and shift to remove the first and last elements of the argument array and assign the removed elements to their corresponding variables so that the returned array contains their variables. So we're changing these two lines. So this is the pop value. So this will equal to array.pop. And this is the shifted value. So this will equal array.shift. And that should be it. Remove items using Splice. Okay, so we've learned how to remove elements from the beginning and end of arrays using shift and pop. But what if we want to remove an element from somewhere in the middle? Or remove more than one element at once? Well, that's where Splice comes in. Splice allows us to do just that, remove any number of consecutive elements from anywhere in an array. Splice can take up to 3 parameters, but for now we'll focus on just the first two. First two parameters of Splice are integers, which represent indexes or positions of the array that Splice is being called upon. And remember, arrays are zero indexed, so to indicate the first element of an array, we should use 0. Splice's first parameter represents the index on the array from which to begin removing elements, while the second parameter indicates the number of elements to delete. For example, we have the array here. Today was not so great. And I'm gonna guess we're gonna get rid of the not so. So we're array splicing 2, so we're gonna start 0, 1, 2. So we're gonna take this one. And we're gonna take 2 items, so this one and the next one. Remove 2 elements beginning with the third element. Array now equals today was great. Splice not only modifies the array it's being called on, but it also returns a new array containing the value of the removed elements. Let array equals, this array says, I am feeling really happy. So for our new array, we're going to, okay, it's just showing us how we can use it. New array equals really happy because we've 0, 1, 2, 3, and we're getting 2, so we're getting just those. We have defined a function, sum of 10, which takes an array of an argument and returns the sum of that array's elements. Modify the function using Splice so that it returns the value of 10. So we have a function here, sum of 10. Change the code below this line and above this line right here, and then it's going to return, it's going to take the array, it's going to reduce, it's going to take each item, and I believe the previous item, and it's just going to keep adding them. So it's going to sum up all the numbers in here. So we need to take, and we need to modify this array so that only numbers that will add up to 10 and we have to do that using Splice. Okay, we need to do R Splice because that's what it's named. So 5, 6, 7, 8. Let's see here. So I think we have to get rid of everything but the 5s. Or we could leave 1 5, 2 2s, and a 1. That would be 2 splices versus 3 splices. I'm thinking, right? All right, so we are going to 5, 6, 7, 8. We're gonna leave these. So we want to start. We go 0, 1, 2, 3. So we're gonna start from the third element, our third index, which is the 4th element, and we're gonna only take 1 item. And then we're going to do the same thing, but now we have 2, 5, 1, no 5, and we have a 2, 1, and we have to get rid of that final. Or can we just get rid of these? We could just get rid of those, right? Yep. So we can do this in 1, actually. Alright. So we're going to start at the second, and we're going to grab 2 of them. So array splice 2, 0, 1, 2, and we're grabbing 2 elements. So we'll take those out, which gives us 5, 6, 7, 8, 9, 10. Add items using Splice. Remember in the last challenge we mentioned that Splice can take up to 3 perimeters? Well, we can go one step further with Splice. In addition to removing elements, we can use that third perimeter, which represents 1 or more elements, to add them as well. This can be incredibly useful for quickly switching out an element or set of elements for another. For instance, let's say you're storing a color scheme for a set of DOM elements in an array. You want to dynamically change a color based on some action. So we have function color change. We have all this stuff. It takes an array, an index, and a new color, and then just passes that to Splice and returns the new array. So our color scheme, we have all these numbers, but we want to take the color scheme and change the color of it. So we're passing in the color scheme. We want the second index. We're going to replace it with that. So we moved this because 0, 1, 2, and we've added the new color. So the new array equals this. This function takes an array of hex values, an index in which to remove an element, and the new color to replace the removed element with. The returned value is an array containing a newly modified color scheme. While this example is a bit oversimplified, we can see the value that utilizing Splice to its maximum potential can have. We have defined a function, HTML color names, which takes an array of HTML colors as an argument. Modify the function using Splice to remove the first 2 elements of the array and add dark salmon and blanched almond in their respective places. Alright, so we're using Splice again. We have our array.splice. we're going to remove the first two elements. So we're going to start at 0, and we're going to remove 2, and we're going to replace them with dark salmon. I'm guessing that this goes in an array. Blanched almond. Unless you can only do one at a time. We'll find out. Alright, so I think it does not accept an array. I'm not positive. But it seems to not. So what we're just doing is we're taking that array and we're just replacing the 0 index with dark salmon and then the first index with blanched almond. So it gets rid of these two. It puts in the two that we specified. Copy array items using Splice. The next method we will cover is Splice. Splice, rather than modifying an array, copies or extracts a given number of elements to a new array, leaving the array it is called upon untouched. Splice takes only two parameters. The first is the index at which to begin extraction, and the second is the index at which to stop extraction. Extraction will occur up to, but not including the element at this index. Considering this, okay, we have weather conditions: rain, snow, sleet, hail, and clear. Today's weather is weather conditions slice. We're gonna start at 1 and take 3. Today's weather will equal snow and sleet. Oh, okay, so this is different. So we start here, and then we tell it what index we want to go up to. So 0, 1, 2, 3 does not get the third one. I don't like how that's so much different in Splice. We have defined a function forecast that takes an array as an argument, modify the function using Splice to extract information from the argument array, and return a new array that contains the elements warm and sunny. Alright, so we are using array.slice. And we're just gonna do it off here. So 0, 1, 2, we want to start at the second index or the third element in the array. And so that we got 3 is warm. Now 2 is warm. 3 is sunny. 4 is cool. So we want 4. So we'll start here and do everything up to 4. Copy an array with the spread operator. While Splice allows us to be selective about what elements of an array to copy, among several other useful tasks, ES6 new spread operator allows us to easily copy all of an array's elements in order with a simple and highly readable syntax. The spread syntax simply looks like this: 3 periods. In practice, we can use the spread operator to copy an array like so. So we have this array, true, true, undefined, false, null. And that array, we are spreading this array into it. So now they're equal. We have defined a function, copy machine, which takes array and a number as arguments. The function is supposed to return a new array made up of a number of copies of the array. We have done most of the work for you, but it doesn't work quite right yet. Modify the function using spread syntax so that it works correctly. Hint: another method we have already covered might come in handy here. So the copy machine, we have our new array. While the number is greater than or equal to 1, it's gonna do some code that we haven't done yet, and it's gonna make 1 less, and then return the new array. All right, so we have our new array, and it wants us to return a new array made up of X copies of the array that we passed. So if we look at this example down here, this should return everything is wrapped. So we're going to push array. No, we're not. We're gonna we have to use the spread. Can we just do that work? I don't think that's what we're supposed to be doing. I think it's something like this. So we're making a new index in the array, and we're assigning it an array of what we've been given. Okay, this doesn't run. I want to look at the hint for this though. Okay, so we did do it pretty much right. They just have one extra step. We created an object, a new object, and instead of doing that, we just put it right in there. So that's cool. That's cool. Alright, let's keep going. Combine arrays with the spread operator. Another huge advantage of the spread operator is the ability to combine arrays, or to insert all the elements of one array into another at any index. With more traditional syntaxes, we can concatenate arrays, but this only allows us to combine arrays at the end of one and at the start of another. Spread syntax makes the following operation extremely simple. So we have this array that has sage, rosemary, parsley, and thyme. And then we have that array, basil, cilantro, and then coriander. That array also has this array inside of it, using the spread right here. That's why we get this long list. That's pretty cool. Using spread syntax, we have just achieved an operation that would have been more complex and more verbose had we used traditional methods. We have defined a function spread out that returns the variable sentence. Modify the function using the spread operator so that it returns the array. Learning to code is fun. So, all right. Learning to code is fun. So we say learning, and then we pass in our fragment, and then we do is fun. Cool stuff. I don't know how many times I've liked down this song, honestly. Check for the presence of an element with index of. Since arrays can be changed or mutated at any given time, there's no guarantee about where a particular piece of data will be on a given array, or if that element even still exists. Luckily, JavaScript provides us with another built-in method, indexOf, that allows us to quickly and easily check for the presence of an element on an array. IndexOf takes an element as a parameter, and when called, it returns the position or index of that element, or -1 if the element does not exist on the array. For example, fruits. We have apples, pears, oranges, peaches, and pears. And if we do fruits index of dates, it returns a -1 because it's not inside. And fruits index of oranges returns a 2 because 0, 1, 2 is the index of oranges. And fruits index of pears returns 1, the first index at which the element exists. 0, 1. Even though it's in here twice. Index of can be incredibly useful for quickly checking for the presence of an element on an array. We have defined a function quickCheck that takes an array and an element as arguments. Modify the function using index of so that it returns true if the past element exists on the array and false if it does not. So we have a function quickCheck. It takes an array and an element. So we got the first array, or okay. So this is the array of elements that we're passing, and we want to check if mushrooms is in there. So we're gonna return and we can just return it because if it doesn't exist, it will be a -1, which will be false. So fruit, or no, we're gonna do array index of element. Okay, so it's not, it wants us to strictly return true or false. So what we're gonna do is we're just gonna, can we do that? We're just gonna do the shorthand here. So if this is true, it will be true, and if it's false, it will be false. Okay. So maybe we can't do that. Let's get a hint. All right. So, because it returns the index, which if I thought about it, and the index can be 0 to 0, 1. So we could actually take this and we could add 1 to it. Right? -1 would be it's not there, so if we add 1, it'd be 0. It might be that we could even just get rid of this. No? No, we can't. Alright, so it needs to be strict. Alright, cool. Iterate through all an array's items using for loops. Sometimes when working with arrays, it is very handy to be able to iterate through each item to find one or more elements that we might need, or to manipulate an array based on which data items meet a certain set of criteria. JavaScript offers several built-in methods that each iterate over arrays in slightly different ways to achieve different results, such as every, for each, map, etc. However, the technique which is most flexible and offers us the greatest amount of control is a simple for loop. Consider the following. So we have a function here, greater than 10, gets passed an array. We have a new array. We have a for loop, let I equal 0. As long as I is less than the length of the array, we're going to do the following, and then we'll increase I by 1. And then it's looking at the array, the current index that we're at with I, and if it is greater than 10, then it's going to push that number into our new array, and finally we return our new array. So greater than 10, if we pass it an array of these numbers, it will return 12, 14, and 80. Using a for loop, this function iterates through and accesses each element of the array and subjects it to a simple test that we have created. In this way, we have easily and programmatically determine which data items are greater than 10 and return a new array containing those elements. We have defined a function, filtered array, which takes array or a nested array and an element as arguments and returns a new array. Element represents an element that may or may not be present on one or more of the arrays nested with array. Modify the function using a for loop to return a filtered version of the past array such that any array nested within array containing element has been removed. Alright, so this takes a nested array, and what we're going to do is that we're going to go through it, and any one of these arrays that contains a 3, we're going to just chop it out. That would be all of them, though. Let's take a look. Okay, so it does want it to be empty. All right. So we're using a for loop. I is going to equal 0, and as long as I is less than our array.length, and then I plus. And then inside our code block here, and then we're going to do a if. And we're going to take the array, we're going to look at the current index, and if it has an index of this element, if it's greater than or equal to 0, and we're gonna remove it. So we're gonna say if it's equal to -1. So that's the check that it's not there. So if this is not there, then we're gonna push I believe that would do it. All right, let's read this again. So we have our for loop. It's going to loop over every item in this original array. We have 1, 2, 3, 4 subarrays here. So it's going to loop 4 times, and if one of these arrays has an index of the element, which is whatever's being passed, if it's equal to -1, meaning it didn't find it, then we're going to take the new array and we're going to push that subarray at that index that we're currently looking at. I believe that will work. I is not defined. You're right. Boom. Create complex multi-dimensional arrays. Awesome. You have just learned a ton about arrays. That has been a fairly high-level overview, and there's plenty more to learn about working with arrays, much of which you will see in later sections. But before moving on to looking at objects, let's take one more look and see how arrays can become a bit more complex than what we have seen in previous challenges. One of the most powerful features when thinking of arrays as data structures is that arrays can contain or even be completely made up of other arrays. We have seen arrays that contain arrays in previous challenges, but fairly simple ones. However, arrays can contain an infinite depth of arrays that can contain other arrays, each with their own arbitrary levels of depth, and so on. In this way, an array can very quickly become a very complex data structure, known as a multi-dimensional or nested array. Consider the following example. No. So we have our nested array. Right here. This is the outermost array. I want to make sure that the text is big enough here. Then we have just 2 levels of depth, and then 2 arrays nested at 3 levels of depth. And then these are even deeper, 2 arrays nested at 4 levels. While this example may seem convoluted, this level of complexity is not unheard of, or even unusual when dealing with large amounts of data. However, we can still very easily access the deepest levels of an array this complex with bracket notation. Now that we know where that piece of data is, we can reset it if we need to. We have defined a variable, myNestedArray, set equal to an array. Modify myNestedArray using any combination of strings, numbers, and booleans for data elements so that it has exactly five levels of depth. Remember, the outermost array is level 1. Somewhere on the 3rd level, include the string deep. On the 4th level, include the string deeper. And on the 5th level, include the string deepest. Not a fan. Oh. Oops. Alright, so we have our nested array here. So these only have 1, 2 levels. So we're gonna make another one. This is 2. And then this is 3. And then, so this is 3 again. And this is 4. This is 4 again. And this is level 5. So we start all the way up here, level 1, 2, 3, 4, 5. Basic data structures add key value pairs to JavaScript objects. At their most basic, objects are just collections of key value pairs, or in other words, pieces of data mapped to unique identifiers that we call properties or keys. Let's take a look at a very simple example. We have a FCC user. Username is AwesomeCoder, has 572 followers, 1,741 points, and has completed 15 projects. Above code defined an object called FCC user that has 4 properties, each of which map to specific value. If we wanted to know the number of followers FCC user has, we can access that property by writing let user data equal FCC user dot followers. So now user data equals 572. This is called dot notation. Alternatively, we can access the property with brackets like so. Notice that with bracket notation, the enclosed followers is in quotes. This is because the brackets actually allow us to pass a variable into be evaluated as a property name. Keep this in mind for later. Had we passed followers in with without the quotes, the JavaScript engine would have attempted to evaluate it as a variable, and a reference error followers is not defined would have been thrown. Using the same syntax, we can also add new key value pairs to objects. We've created a foods object with 3 entries. Add 3 more entries: bananas with a value of 13, grapes with a value of 35, and strawberries with a value of 27. So we're going to want to take foods, and we're adding bananas, and it is going to equal 13. And we're going to add 1, 2, 3 things. The final one's a value of 27. This one's a value of 35. These aren't bananas, they're grapes. And these aren't bananas, they're strawberries. Modify an object nested within an object. Now let's take a look at a slightly more complex object. Object properties can be nested to an arbitrary depth, and their values can be any type of data supported by JavaScript, including arrays and even other objects. Consider the following. Man. So we have a nested object. It has an ID, it has a date, and then it has data, which is its own object with a bunch of different stuff, including another nested object. Nested object has 3 unique keys: ID, whose value is a number; date, whose value is a string. All right, hold on. Hopefully we're okay now. All right, where were we? Whose value is a string. Let's just reread this whole thing here. Nested object has 3 unique keys: ID, whose value is a number; date, whose value is a string; and data, whose value is an object, which has yet another object nested within it. While structures can quickly become complex, we can still use the same notations to access the information we need. Here we've defined an object, user activity, which includes another object nested within it. You can modify properties on this nested object in the same way you modified properties in the last challenge. Set the value of the online key to 45. Ah, man. All right, so we have user activity, and we want to change online 45. So we use user activity, and then we're looking at data. And within data, we're looking at online. And that's going to equal 45. Right? Right. Access property names with bracket notation. In the first object challenge, we mentioned the use of bracket notation as a way to access property values using the evaluation of a variable. For instance, imagine that our foods object is being used in a program for a supermarket cash register. We have some function that sets the selected food, and we want to check our foods object for the presence of that food. That might look like, this might look like, we have our selected food, function that returns the get current food. We can pass it the scanned item. Inventory equals foods, selected food. This code will evaluate the value stored in the selected food variable and return the value of that key in the foods object. Got a tickle I just can't get rid of here. I'm out of G Fuel. I'm gonna go get some water. I'll be right back. All right. Defined a function check inventory, which receives a scanned item as an argument. Return the current value of the scanned item key in the foods object. You can assume that only valid keys will be provided as an argument to the check inventory. So we're just doing a lookup here. We're checking the inventory of the scanned item. So we want to return foods scanned item. So we're looking at foods scanned item will be apples. And a few lessons ago, it told us to remember this. So that's why. So I will just look up apples. Apples is 25, so we're returning 25 here. Use the delete keyword to remove object properties. Now you know what objects are and their basic features and advantages. In short, they are key value stores, which provide a flexible, intuitive way to structure data, and they provide very fast lookup time. Throughout the rest of these challenges, we will describe several common operations you can perform on objects so you can become comfortable applying these useful data structures in your programs. In earlier challenges, we have both added to and modified an object's key value pairs. Here we will see how we can remove a key value pair from an object. Let's review our foods object example one last time. If we wanted to remove the apple's key, we can remove it by using the delete keyword, like this. Delete foods.apples. Use delete keyword to remove oranges, plums, and strawberries keys from the foods objects. So we want to delete foods.oranges and delete foods.plums and delete foods.strawberries and delete foods. Oh, that's it. That's it. Organisms. Okay. There we go. Got him. Check if an object has a property. Now we can add, modify, and remove keys from objects, but what if we really wanted to know if an object has a specific property? JavaScript provides us with two different ways to do this. One uses the hasOwnProperty method, and the other uses the in keyword. If we have an object users with the property of Alan, we could check for its present in either of the following ways. Wow, I didn't know this. We've created an object users with some users in it and a function isEveryone_here, which we pass the user's object to as an argument. Finish writing this function so that it returns true only if the user's object contains all four names, Alan, Jeff, Sarah, and Ryan, as keys, and false otherwise. So we're going to return Alan. Wonder if we can do look like we can do that. There we go. Let's look at their hint though, see how they did it. Oh, that's nicer. I wanted to see if they had a better version of this. It doesn't look like it. But I like this. I didn't know that you could check multiple. Or you could do the shorthand. Alright, iterate through the keys of an object with a for-in statement. Sometimes you may need to iterate through all the keys within an object. This requires a specific syntax in JavaScript called a for-in statement. For our users' objects, this could look like this. For let user in users, console.log the user. In the statement, we defined a variable user, and as you can see, this variable was reset during each iteration to each of the object's keys as the statement looped through the object, resulting in each user's name being printed to the console. Note: objects do not maintain an ordering to stored keys like arrays do. Thus, a key's position on an object or relative order in which it appears is irrelevant when referencing or accessing the key. We've defined a function, countOnline. Use a for-in statement within the function to loop through the users and the user's object and return the number of users whose online property is set to true. So for objects in object, and I think that it was blue because that's a word that we can't take. So in here we're going to see here. Let online equals 0 and online. Let's see here, online plus equals, and we're gonna test if he's online or not. So we have the object, is it online? And if it is, we're gonna add 1, otherwise we're gonna add 0. And then we're gonna return online. Alright, so first we set online equal to 0. And then for each object that we passed, we're going through it. We're checking its online status. If it's true, we're adding 1 to online. If it's false, we're adding 0. And in the end, we're returning online, which should be the count. Should be 2 for this. Yeah. Yep. Let's just try it another way, I guess. Alright, well, let's get a hint. See what I'm doing wrong. Oh. Okay. Oh no. Undefined. What's going on with this lesson here? It's just totally not letting me do this. Okay, so because user is a variable, you can't use dot notation. All right. So if we did instead, if user line, then we can do online plus plus. Okay. Let me try to understand this. So, for let user in object, this is a variable user. Get it, but I don't. Because it's kind of different than PHP, I guess. Like, I wouldn't expect to have to use the object and then look up the user. Let user in object, so that, okay, I see. So that's gonna get just the strings of the users. Okay. So then we need to use that to look it up. Okay. Alright. Cool. Generate an array of all object keys with object keys. We can also generate an array which contains all the keys stored in an object using the object keys method and passing in an object as the argument. This will return an array with strings representing each property in the object. Again, there will be no specific order to the entries in the array. Finish writing the getArrayOfUsers function so that it returns an array containing all the properties in the object receives as an argument. GetArrayOfUsers, users. Pass the objects we want to return. Object keys for this object should return an array of all the keys for the object, so I think that should do it. It does. Modify an array stored in an object. Now you've seen all the basic operations for JavaScript objects. You can add, modify, and remove key value pairs. Check if keys exist, and iterate over all the keys in an object. As you continue learning JavaScript, you will see even more versatile applications of objects. Additionally, the optional advanced data structure lessons later in the curriculum also cover the ES6 map and set objects, both of which are similar to ordinary objects but provide some additional features. Now that you've learned the basics of arrays and objects, you're fully prepared to begin tackling more complex problems using JavaScript. Hooray! Take a look at the object we provided in the code editor. The user object contains 3 keys. The data key contains 5 keys, one of which contains an array of friends. From this, you can see how flexible objects are as data structures. We started writing a function addFriend. Finish writing it so that it takes a user object and adds the name of the friend argument to the array stored in user data friends and returns that array. So we have a user, Kenneth, age 28. Here's all his data with his friends inside. So we have this function here, addFriend. Takes a user object and the friend. So right now we want to console.log addFriend user Pete. And it should return the array of friends after we've added Pete. So it should be an array of Sam, Kira, Tomo, and Pete. All right, so we have an array in data. So let's see here. We're going to return user object. And we're looking at the data. Specifically the friends data. And we're gonna push our new friend. I believe that's all we have to do. Alright, so we use the spread operator that we learned earlier. I don't think push actually returned. Does push not return? So we'd have to do that and then return. But this here, we'll use the spread operator, and we're just making the array be the existing array spread out and then friend after. I'm sure, well, let's take a look at their hint here, see how they did it. So they used push, and then, which is a little nicer, maybe, than our... It is way nicer. So they just data and our friends. But first they user object data friends pushed the friend. Alright. I'm actually gonna take a second right now to donate. I've been doing this a while, and I don't mind donating a few dollars. Maybe it will get this to stop popping up. Alright, so we've donated. And we're done with this section. So, let's see here. Tomorrow we'll be moving on to introduction to basic algorithm scripting. Exciting, exciting. For now, I think it's time to call it for the afternoon. It's 3:17. We've done a couple hours. But it was two relatively small sections, so it's good to get them done. Anyway, I will be back tomorrow with some more free code camp doing basic algorithm scripting at 1 p.m. EST. I'll be here later tonight at 8 p.m. EST for some Clash Royale, if you're into that. And again, I'm here every Monday through Thursday, 1 p.m. and 8 p.m. EST. Throw me a follow if you like. Turn on the notifications. And you'll be alerted when I go live. Thanks for stopping by.